Alright. A particle is projected from the foot of an inclined plane which makes an angle 45 degrees with the horizontal. The initial velocity is u and angle alpha to the horizontal. So, the one word that always gets me is this the horizontal. I always forget to read it. So what does that mean? Right, you told me earlier. So this is 45, which it is, and this is my throwing angle. That's my throwing angle there. So here to here, different color please. Here to here, angle wise, is alpha. So what do I want to put in here? Alpha minus 45, okay? Alpha minus 45 is what I want in there. So if I establish my throwing angle straight away, it's going to be the usual. It's going to be u cos alpha minus 45 and u sine alpha minus 45. That one for parallel, that one for perpendicular. All right. So we established that early on. Going to do my gravity triangle. Is face down these for now. Beta. Okay. And beta, beta, beta. G. This one here. Oh, sorry, not beta. So G cos 45, which is G over root 2. G sine 45, which is also G over root 2. So that's G sine 45 and G cos 45. All right, 4 equations. All right. All right, we got it. Now, I'm going to make my 4 equations first. And once I make my 4 equations, then I'll address the question then. So, everybody happy with u cos alpha minus 45 minus g over root 2t dy u sin alpha minus 45 minus g over 2t. Sx is going to be ut cos alpha minus 45 minus g over 2 root 2t. Finally, sy equals ut sine alpha minus 45 minus g. Who got that far and had all 4 equations? Happy enough. So you had all 4 equations. Everything was cool so far. Yes? Yes, it is. Thank you. A half gt squared, not a half gt. Always good to take that time to look over them again, isn't it? Most of my mistakes occur here. Once I have these perfects, I tend to do quite well then. Now, alright. So what does this mean? If the angle at which the particle meets the plane of landing is B, so you come down here, you continue your landing, and you hit the angle, you hit it at an angle B. Everybody cool with that? So imagine this is the plane here, and this is zoomed up version. Imagine I hit it at 5 downwards and 3 across. What would that mean? 5 down and 3 across. What's the landing angle then? I could draw it a different way, couldn't I? I could draw it as I could draw something like this. I could draw it as 3 across, 5 down. So 3 and 5, and that's my angle beta. Are we cool with that? And tan beta would be 5 over 3. Now you gotta remember tan beta. Beta is your landing angle, so tan beta equals minus Vy over Vx at time of flight. That's what you're looking at. tan beta equals minus Vy over Vx time of flight. All right, let's get the time of flight. Get the time of flight. Anybody? Yeah, that's like 0, right? So put this equal to 0. Then you're going to get ut sine alpha minus 45 g over 2. Or so equal to t squared. And the t's cancel. Up. And g equals, no, not g, t equals 2 root 2 u sine alpha minus 45 all over. So we'll check now. Yeah. Anybody get the time of flight? From Similar? We're all good. Alrighty. Now, next thing I'm going to do is going to sub that into my Vy and my Vx. So it's not an easy substitution. So here. Top and look. That's my answer I got a second ago. And purple. Alright. Let's do Vx now. Vx equals u cos alpha minus 45 minus 2 root 2. It's going to be 2 root 2 g u sine alpha minus 45 all over. There's a root 2 there, isn't there, underneath? There's also a g underneath as well. So we just integrated the g over root 2 here and here. Is that okay? So we integrated all in one go. Now, they cancel. The root 2g and the root 2g cancel. So what we should be left over with is u cos alpha minus 45 minus 2 sin alpha minus 45. We're done. That's the Vx done. Now we're going to move on to the Vy. Vx is done. Now we're on to Vy. Vy, same deal. What has to happen with the Vy? Can anybody tell me? There can be no dispute. It has to be a guaranteed negative. Okay. So in this case, you could argue that you could find a value of alpha that would make it negative. You probably could. In the next case, it always has to be negative. Okay. So here's what we're going to do. We're going to do u sine alpha minus 45. It's exactly the same thing as last time. So I can just reuse what I had last time, can't I? Because it's exactly the same thing. So it's going to be minus 2. Oh, there's a u there as well, by the way. 2u sine alpha minus 45. So that was handy. Minus u sine 45. Right. Next thing, we're going to know what tan beta equals. So tan beta will equal minus my two answers divided by each other. And an angle. Tan beta equals minus Vy over Vx, which is u sin alpha minus 45, all divided by u cos alpha minus 45 to u sine alpha minus 45. Okay. Now, you look at that, you look at the answer and go, why doesn't my one look like that, right? Now, you make a note of the differences. Do you see alpha minus 45 anywhere? You don't, do you? That's your first job. Get rid of all the alpha minus 45s using trigonometric rules on page 14. Go to page 14 of your tables, and I'd like you to find me something I could use for this part here and this part here. As I said the other day, go fish. So, if you will, I'm looking for a rule for cos alpha minus beta, and I'm looking for a rule for sine alpha minus beta, or sine A minus B. Shh. Anybody find the rule yet? Call it out to me. What you get for cos A minus B? Come on. Thank you. Cos A, cos B. Awesome. And next one. Yeah. Now, we're going to alter this slightly. So what we're going to do is anywhere I see A, I'm going to put in alpha. Anywhere I see B, I'm going to put in 45. And I'm going to do the same thing for the second one. That's going to be alpha minus 45 as well. Alpha 45, alpha 5. Now let's see what happens. I believe we're going to get 1 over root 2, 1 over root 2 cos alpha, plus 1 over root 2 sine alpha. And then on the next one, I'm going to get 1 over root 2 sine alpha, and then minus 1 over root 2 cos alpha. Alright, now, what I'm now going to have to do is I'm going to have to combine all of this together. Just for the denominator, for the domain, just the denominator. I'm just working on the denominator at the moment, right? So I'm going to factorize out u. Is that okay? Just pretend the u doesn't exist for a minute, and whatever the answer is, we're just going to stick a u beside it. Okay. So let's write down u cos alpha, which is 1 over root 2 cos alpha plus 1 over root 2 sin alpha. Then we're going to take away 2 times sin alpha minus 45, the blue part. 2 times it. So multiply both of them by 2, by minus 2 in fact. So this part in pink, I'm going to multiply all that by minus 2. And what we're going to get is minus 2 over root 2 sine alpha and minus plus 2 over root 2 cos alpha. Right, what should happen is I should get 3 over root 2 cos alpha. There's going to be a u in there. And then there's going to be 1 over root 2 sine alpha. Take away 2 over root 2 sine alpha, which is minus 1 over root 2 sine alpha. Alright, this is a great mess we got ourselves into. The only way through it. Now we're going to have to go back up and figure out how to change everything into tans, which is going to be fantastic fun. Alright, so alright, so what I'm currently doing next is I'm taking this colossal equation here, which I'm currently shading completely in blue, and I'm going to put in bits and pieces using the equations below. Is that alright? So, I'm going to get rid of that. I need a bit of space here. Get rid of you. Don't need you anymore. And I don't need you anymore. So, here we go. Here we go. All right. Again, tan beta equals u sine alpha. And if I remember correctly, u sine alpha is, it'll be multiply this by u, isn't it? There's a cos alpha there as well. Multiply all that by u. So it's going to be u over root 2. U over root 2 sine alpha minus u over root 2 cos alpha. And then on the bottom, we're going to have 3 over u root 2. You know what? I'm going to get some common denominators. So it's going to be u sine alpha minus u cos alpha all over root 2. And then on the bottom, you're going to have 3u cos alpha. Now I'm smiling because I know I have it. Minus u sine alpha all over root 2. All right. Everybody cool with that? Now, what I always tell anybody I'm teaching is that what you learned at junior cert is if I had 3/4 divided by 2/3, you guys learned to turn the 2/3 upside down, do 3/4 multiply by that, didn't you? So all I'm going to do is going to take that one up and turn it upside down, and I should be in business. So it's going to be u sin alpha minus u cos alpha over root 2 multiplied by root 2 over 3u cos alpha minus u sin alpha. Now, what cancels? Well, I could factorize out u, couldn't I? I could factorize u out the top, so if I got rid of that and that, and put the u on the outside, I could do the same thing down here. I could factorize out the u, put the u on the outside. Those two u's will cancel. The root 2's will cancel. And then what I'm left with is sine alpha minus cos alpha all over 3 cos alpha minus sine alpha. Now, this is where you compare back to your original answer. Look at the 3. The 3 is significant, okay? I want 3 cos alpha to turn into 3. That's the hint. 3 cos alpha to turn into 3. How would you do that? What would I divide it by? What happens if I divide it by cos alpha? What happens if I divide that one by cos alpha? And I divide this one by cos alpha and this one by cos alpha. Now, some of you are wondering, can I do that? All right. So I'll give you a much more basic example to explain I can. 8 plus 6 divided by any two even numbers I'm choosing, 2 plus 4. Everybody agree that that's 14 divided by 14. Choose any even number of your choice. 2, 2, 2, 2. Basically the same thing I'm doing there, isn't it? And then your answer will be 4 plus 3 over 5 plus 2, which is still 7 over 7, which is still 1. I'm allowed to do that. Okay? Now what happens next? Sine alpha over cos alpha? Yeah. Tan alpha minus 1 over 3 minus tan alpha, and all that equals tan beta. Okay? And you're done. Simple, yeah?